أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه وسلم. We give thanks to Almighty Allah, the uncreated Creator, the one who has bestowed human being knowledge, and He has raised him by that. He taught man what he did not know. We ask Allah to bless Prophet Muhammad sallallahu alaihi wasallam, who made us know that searching for knowledge is very essential. I am Ojakunle Ridwan Babatunde. I'm here to discuss and explain and teach us certain things in chemistry, especially SS2 chemistry. Here I am to discuss today. I shall be talking about the third term scheme of work for 2019-2020 academic session. Here goes the weeks and the topics. Week 1, we have electropotential and electrochemical cells. Week 2, we have hydrogen and its compounds. Week 3, we have oxygen and its compounds. Week 4, we have water solution and solubility. The same thing goes for week 5. That will be the completion of the topic from week 4. Week 6, we have chlorine and its compounds. Week 7, we have chlorine and its compounds, its completion. Week 8, sulfur and its compounds. Week 9, the completion of sulfur and its compounds. Week 10, we have nitrogen and its compound. Starting from week 1, electrode potential. What do we mean by electrode potential? Before now, we talked about electrolysis in second term. We define electrolysis as the chemical decomposition of a compound into its component ions by the passage of electric current. Either the substance is in molten form or in solution. We also discussed, we defined some terminologies like what electrolytes are. Electrolytes, these are substances that can conduct electricity either in molten form or in solution. When electricity is passed through, an electrolyte can get decomposed. What are electrodes? Electrodes are the rods or plates through which electron enters or leaves an electrolyte. But here now, I want to talk about the meaning of the concept of when we say electrode potential. Two words there, electrode, then potential. We want to look at the potentials that electrodes have. And how is this potential? How can it be certain? Now, this potential can be certain. Taking for instance, when a metal electrode is placed in a solution of its salt, a metal electrode, be it a rod or a plate, it is placed into a solution of its salt. Two possible things or reactions can happen. Two possible reactions may occur. One of the first reactions that we can see is that there is a tendency for the metal to lose electrons and form metal ions. The electrode that is dipped, that is placed inside a solution of its salt, may lose electrons and form metal ions. At the same time, the metal ions that are present inside the solution, they have the tendency to accept electrons from the metal atoms that constitute the electrodes. eventually an equilibrium will be established between the metal, say metal M, and its ions, say metal Mn2 plus, Mn plus. What does that mean? The M plus there, it is telling us the oxidation state of the metal ion in question, or of the metal in question. Now, that is, we have the metal in a solid form. It is possible we have it going forward, forming its ion. Then there will be loss of what? Loss of certain number of what? Of electrons. Equilibrium can exist whereby you are going to have, you can also have the ion gaining electron. When the ion gains an electron, it can be deposited in the form of metal. Now, the overall charges carried on an electrode in the above two reactions depends on where the equilibrium position lies. That means the equilibrium position can move forward or backwards. If it happens that the equilibrium position falls or goes forward, it means, what are we going to have? Going forward, we are going to have more ions inside the solution. That is, the electrode will be dissolved inside the solution, and you have more ions being formed. That is to say, if let's start from this place. If the equilibrium lies on the left hand side, it means you are having Mn plus gaining electron and is forming Mn solid. Reduction is dominant. We all know that when we are trying to define reduction or oxidation, this is gain of electron. So we know that gaining of electron will make a particular species to be reduced. Particular ones will reduce. So that means Mn plus gaining electron is undergoing reduction. That means reduction is dominant in such a metal ion and a metal atom system. If the reduction is dominant, the electrode will carry positive charge. While if the equilibrium lies on the right hand side, meaning that we are having the metal atom being converted to what? To metal ion, as we have Mn plus aqueous there. So the metal atom is turning or is forming ion with the loss of what? Electron. What is oxidation? Oxidation is loss of electron in terms of electron transfer. It is loss of electron. So that means oxidation is dominant and the electrode will carry negative charge. In either case, there is a potential difference between the electrode, that is metal electrode, and its surrounding solution. Such a potential difference that exists is called the electrode potential and is abbreviated as what? As capital letter E. Because there will be movement of electrons. Is either that the electrons are coming from where? From the electrode to what? To the ions in the solution. So when the ions in the solution are getting electrons from the electrode, the electron will be rendered to become positive. But if the electrons are coming from the what? If the electron is gaining the electron, am I communicating? If the electron is gaining the electron, so that means the electrode will become what? Will become negative. In either case, how can the electrode gain electron? When the atom is getting dissolved inside the solution, forming what? Forming, like as we have here, forming Mn plus. If we have M solid turning to Mn plus aqueous, gaining electron, that means the electrode would do what? Will carry negative charge. because the electrons that are embedded in the atom in its solid form mx, in its solid state in atomic form, will be left on the electrode as it is getting dissolved into the solution. So that will make the electrode to become what? To become negative, and it will possess more negative charge. So potential difference that is now generated, or the work done, or the energy that is required to drive a unit charge between 2 points or ends in a circuit, is what we call the electrode potential. If it's not related to the electrode, now we call it the electrode potential. What do I mean? Look at this diagram. Diagrams A and B that follow show establishment of electrode potential for reduction and oxidation respectively. From the reduction part of the diagram, we have copper rod, that is copper metal, dipped into its solution. 1 molar copper 2 sulfate. What would happen, or two things can happen as we have earlier said. It is possible that the copper rod would be dissolved and form ions, or we have the copper ions getting deposited. But the possible reaction, the actual reaction that will take place here, is that the copper atom would get what? The copper ion rather, sorry, the copper ion would gain electron, will acquire electron from the what? From the electrode, and will become deposited as copper what? As copper atom, as we have in the reduction party, meaning that it will gain electron. The possible one that can happen here is that is why the longer arrow in each of the equations there point to the direction the reaction proceeds. So for the reduction, we have the longer arrow downwards. So it's telling us that the copper Cu2 plus is gaining the electron, and it will become deposited as a copper atom. Now to the other one, we have the copper, the zinc, the oxidation part of the explanation of how electrode potential can be established. We have zinc dipped inside the solution of zinc sulfate. We have two possible reactions here as well. Zinc's atom can be converted to zinc ion. But what will happen here? What will happen here is that we are going to have a zinc atom losing 2 moles of electron and forming zinc ion. So that's why we have the longer what? We have the longer arrow pointing towards that direction. So loss of electron is what? Is oxidation. Now there is a kind of energy work done for the electrons to be moved. So this work done is what we refer to as electrode potential. It will be positive. For what? For reduction process. Why? Because the electrons, that is why we have the copper rod there having positive on it. Why is that happening? It will happen because the electrons are being supplied from the copper rod into the solution for the copper ions to get deposited. So it will not render the copper rod dipped into it to become positive. So this reduction will have a positive value of electrode potential. That is the work done that is required to drive the electron from one point to another. When you have the interface of between the copper rod and the solution of its salt, it is copper sulfate. So the energy that will be required to drive the electrons in between that, so will be positive. While the other one, which is the oxidation part of it, we are going to have the zinc rod to be negative. Why? Because as the zinc would prefer to get dissolved into the solution of its salt. When it gets dissolved, it is oxidized. It will now leave excess electron on the zinc rod. As it leaves excess electron on the zinc rod, so the electrode potential of the zinc ion and zinc atom system or zinc electrode system will be what? Will be negative. Now, there is something we call standard electrode potential. Electric potential vary from one metal ions or metal electrode system to another. It means each system has its own value of a standard electric potential. The electric potential of a given system depends on three things: the overall energy change, that's number one, the concentration of ions in the solution, and the temperature. Now, for fair comparison between electric potential values, what do we use as scientists? We need to choose a standard to measure what the values of the electric potential of other metal ions / metal system will be. Now, hydrogen has been chosen internationally worldwide by scientists as an arbitrary standard with an electric potential value of 0 at all temperature. So if we want to measure the potential, the standard electric potential of any metal ions / metal electrode system, if we want to measure it, we have to take hydrogen as the standard so that it can be possible for us to do the what? To do the measurement. Now, if you now measure the electric potential of a particular metal ion or metal system, so the value we get will be the standard electrode potential, having taken hydrogen as the standard. If we want to define the standard electric potential now, we will define it as the standard electric potential of a metal ion or metal system is the potential difference. What would the potential difference? That is the work done in moving an electron or in moving a charge between 2 points in a circuit. The work done that is required to move a charge between 2 points in a circuit. So now, metal ion is the potential difference set up between the metal and 1 molar solution of its ions at 25 degrees Celsius. So, like I have said, it is arbitrarily taken that the standard electric potential of hydrogen ions / hydrogen gas system as well is 0. How do we measure standard electric potential? When we want to measure standard electric potential for any metal ion or metal atom system, we will take hydrogen as our standard. Taking for instance, if we want to measure the standard electric potential of copper ion and copper atom system now, if it is being measured, its half cell is connected to the hydrogen ion and the hydrogen gas system by a short bridge. Now, when it is connected, it is discovered that the voltmeter shows a reading of 0.34 volts. So this value that is given, it is the standard electric potential of what? Of copper. You are going to have a voltmeter connected when we are trying to measure the standard electric potential. So whatever the voltmeter reads at that point in time will be the standard electric potential of such metal that is connected to the what? To the hydrogen ion / hydrogen gas system. Now the half reactions at the copper and hydrogen electrode show that electron flows from the hydrogen electrode to the copper electrode. Meaning that if you want to talk about it normally, we will say that oxidation takes place at where? It takes place at the hydrogen side, while reduction takes place at what? At the copper side, because it is one that gains the electron. Now, look at this diagram now. This diagram has a complete circuit showing the voltmeter, the electron flow. We have the copper electrode, we have the platinum electrode. So we have the hydrogen gas system here. We have the solution of hydrogen ion here. We have the copper sulfate solution here. So this setup is used to measure the standard electric potential of copper. So at the left hand side here we have the copper rod dipped in its solution. At the right hand side there we have the hydrogen gas in its solution. Now the value that the voltmeter here reads gives us the standard electric potential for copper. We can also do it for other systems, like maybe zinc ion and zinc atom system. We just connect it to the hydrogen at the right hand side here. When we connect it here, the value that this thing reads, the value that the voltmeter reads will give us value of the standard electric potential of zinc, and the same thing applies to magnesium and other metals if you want to read their standard electrode potential. Now, this heading gives us the standard electric potential of some common metal ions or common metal system when they are connected to hydrogen, as we have it here. So, to know what their potential is, lithium ion system to lithium atom, we have minus 3.04. Potassium ion system to potassium atom, we have minus 2.92. We have calcium ion to calcium atom system, minus 2.87. Sodium ion to sodium atom system, we have minus 2.71. Aluminium ion to aluminium atom system, we have minus 1.66. We have zinc system, zinc ion to zinc atom system, we have minus 0.76. Hydrogen is standard, it is 0.00. It is the arbitrary set standard to measure others. Ag plus, that is silver ion to silver atom system, we have plus 0.80. We have copper ion to copper atom system, we have 0.36. Au plus to Au plus to Au, that is this gold ion to gold atom system, we have plus 1.68. This means that the substances that usually have a negative value of the standard electric potential, they are likely to serve as the anode and they easily get oxidized. Why the ones that means because they can readily lose their electrons, as we have lithium can readily lose the electron when it is connected with the hydrogen system, with respect to the hydrogen system. But when silver, it has positive value. Why does it have positive value? It's because when it is connected to the hydrogen system, it will prefer to get electrons, to gain electron. So that's why it has a positive value when it is read on the what? On the volts meter. So these things are very important when we want to discuss electrochemical cells. It will help us to know which substance or which system can be paired up with another system, especially when we want to build cells. Yes, we want to build electrochemical cells, be it the primary cell or the secondary, that we shall discuss in the next topic by the grace of God. Because if you do not know the electric potential of these systems, we will not be able to set up two half cells that we can use to produce a particular electrochemical cell, as we have the different kinds of cells that we'll talk about next lesson. So summarily, if we are asked what is electropotential? Electropotential is this kind of work done that helps us to drive, or in driving electron between the interface of a metal atom and its ion. Metal atom is the electrode that's dipped inside what? Inside its solution, as we have here now. We have A and B. We have copper being dipped into its solution. We have B here. We have zinc being dipped into its what? Into its solution. That means we can see that copper rod has positive. Why is it like that? It tells us that the electrode would release its electrons to its ions, and it will prefer that the ions are deposited. So that is why this one has a standard reduction potential. So, and it will undergo reduction. This one has oxidation. Standard, it will get readily oxidized. It will get readily oxidized. Why? Because as it is, the electrode here would give its electrons out, and we know lots of electrons is oxidation. I would like to stop here. So by God's grace, lesson 2 would emphasize much on what electrochemical cells, what they are. Inshallah Rahman. I pray Allah subhanahu wa ta'ala increase us in understanding. So I would emphasize on the importance of this electropotential as regards building electrochemical cells. Wassalamu alaikum wa rahmatullahi wa barakatuh.